All right. So welcome everyone to Santiago Castro Defense. I met Santi quite a few years back. It was 2016. We met at the conference in Costa Rica, in Peronia, where Santi was presenting the research that he was doing on humor understanding. And we got to talk at that point. He shared about his interest in research. The thing that I noticed about him at that point was his passion for research, like true passion and true interest in addressing problems that are difficult, like humor, for instance. And also his curiosity, which eventually he maintained, both passion and curiosity he maintained over the years. Then in 2018, he joined a PhD program here. And he worked on several projects that you'll get to hear more today on multimodal addressing different aspects, especially thinking of how to get these models for real life settings. He worked with multiple collaborators, many of whom are now here, whether in person or on Zoom. And you'll again hear about the projects that he worked on. He also did several internships at Netflix, Adobe, Google. One thing that I really appreciated about Santi is that he maintained his ties to his home university in Uruguay and the NLP research that eventually keeps that in this track and continue working on research projects with them. I also saw this as an opportunity for myself. I got to meet wonderful people doing very cool research in NLP in Uruguay. Aside from all this, he also acted as the sysadmin for our lab, and given how large-ish our lab is, I think that was not an easy task. And he kind of did that often silently. I didn't really know about all the things that were going behind the scenes other than seeing things done, which was actually pretty cool. And generally, like just lifting everyone's spirits with his humor. I guess his interest in humor research was not necessarily too far away from his character. And one thing that I would say early on when we started working together, I asked him what he likes to do, and he told me he likes to help people. And I guess this is a very good summary of who Santi is. He likes to help people, helping a lot through research in the sense of full collaborators and also in general in the lab. So with that, I'm excited to hear a summary of 1 hour of 6 years of
Sure. Thanks so much, Rada. Yeah, I sound like a good person. Really good introduction. Thanks everybody for coming. Today you had the pleasure of seeing me in suit for the first time. Some have already, yeah. And I hope the food is good. If not, it's Andrew's fault. Because he ordered the food, and thank you, Rada, for paying for the food. I wasn't asking her, but she offered. All right, so today we're going to talk about video understanding through language in real life settings. And my name is Santiago. Let me start by motivating this. Like, what is video present in our lives? Video is present when we, like, for example, watch content on YouTube from content generated actually by all our users like us. Or like when we watch movies and TV series, when we browse random content on TikTok and Instagram, when we record our favorite memories with our phone, and even we're starting to see more usages at home, like on security concerns and also helping with our chores. And we could argue that video these days is pretty much everywhere. And in what ways, in how do we use like video as users, as people? So as end users, we generally like do things like searching for content or trying to discover similar content. Or if we're like editor users, we're trying to like create content. We do things like creating summaries or rate content, like such as to avoid kids watching adult content. We're trying to recognize and organize objects and characters, like for example, to create these summaries, these video summaries, or we're trying to create subtitles to reach wider audiences and create artwork to share our work with the world. And all these use cases have tasks associated with them that we try to tackle in the academia. However, I argue that laboratory setting and real life are different. There's an important gap between what users want to do and we are actually doing in academia. And I classify these problems into three categories. The ones that relate to data, the ones that relate to methods and evaluation. I'm going to start with data. So on the data aspect, I argue that there are some domains we overlook, such as daily life situations and nature. There are behaviors we generally ignore in the research area, like sarcasm and deception. On the method aspects, we many times rely on task-specific methods, such as when we fine-tune some method like clip, and then we specialize in one task, which also incurs in something that is called catastrophic forgetting, that this new model that we created is not suitable anymore for the task it was originally trained on. And also there's like domain gaps, like it works in like, I don't know, outdoor settings, but it doesn't work on indoor settings, meaning that all in all, it makes it impractical because you end up needing a different method for each task and domain. And finally, on the evaluation side, we rely on unrealistic evaluations, such as using multiple choice, which employ distractors that are generally easy to spot. And we employ noisy metrics such as like blue and rouge and others. So if we want to build these systems that like we want them to work on real life for video understanding, to work for people, we need to address these and other questions on how to solve this. And these are the questions I asked myself to solve, and I'm going to go through in this presentation. I'm going to read them out loud. The first one is if we can build a language-based video understanding benchmark suited for overlooked real-life domains such as daily situations and nature. Thus, combining vision and language help better recognize natural human behavior through video. Can language be leveraged to build an automatic evaluation framework for video understanding that better reflects real-life situations? Can large pre-trained image text alignment models be used for robust zero-shot video understanding? Can we align vision and language models so that they better generalize to unseen verb-object compositions? All right, so I'm going to go through multiple sections. At the beginning, I'm going to go faster, especially since I did my proposal before and the committee is aware of the first part. So but I still wanted to do a quick overview, so I'm still going to present. I have like five sections of content, okay? And the last one is I'm gonna take a bit more time. So this is the first one, which is more on the data aspect that I mentioned, is understanding daily life situations in video. This ended up in a paper published at Heilbron 2020 with these people. So, why do we need this like daily life situation data? At least back in the day when we were doing this, there was a bunch of work using TV series and movies, which have scripted dialogues, acted moments, crisp audio, and pixel perfect moments. And also there were some like situations that became closer to real life things. However, they were like kind of on the short side and pretty particular. But if we want to build systems that work at home and understand people's situations, we need to like understand the stories that happen in our daily life. So that's what we did. We built a benchmark we call Live QA. Here are some different moments, different screenshots from the dataset. So I'm skipping the whole data collection, curation, filtering, and so on. And this is an example. Like this shows one screenshot, the dialogue, and then there's like questions, and the model has to select the correct one out of the many options. Okay. Quick stats. The videos are like middle down, between a minute and a half. Generally 2,300 questions. Audio, vision, text. The text is the subtitles. And I'm gonna present some results. Yeah, I'm gonna go fast in this section. So we first measure human baseline with 90% accuracy, while random would be 25%. We also include some like simple baselines to like show some biases from the data. And then we also consider ones that just look at the question, which again is also some biases, and you could go further. Yeah, this is from another work. Yeah, actually from Newstalk. Then we started including more modalities, and we consider some other LSTM-based methods, like BIA, which was kind of famous in the moment. And now, yeah, anyway. memory networks were a thing also back in the day. We also consider what a human can do with just using the audio, because sometimes it's like a means of the audio. You could argue it's not the same, but it's a good proxy. Yeah, still we couldn't like pass like these biases with this. We also considered only the video here. And finally, when we consider everything, we get the best methods, which was a method like based on a method proposing to be QA dataset. But still, there's like an important gap with how a human can do. And we still believe this is a challenging task for models because the situations involve like minute-long videos, and you need to understand what happens in them. I would argue even models as of today struggle with that. You can stop me if you have questions. I assume you don't, so I continue. Now I'm going to talk about, so I talked about daily life situations. Now I'm going to move on to another overlooked domain, which is nature. This section is called video understanding in the wild scenarios, in the wild scenarios. This is just one slide for the interest of time. This work ended up published at Calling 2022 with these people. So this is just one slide. We proceeded in a similar manner to the previous one. We focus on nature. We identify these domains. The motivation was a bit different. It was more about like you are sending like a robot into the wilderness, and then you want to understand what data came in because it captures hours and hours of video footage. But one of the highlights is that we first propose a new format different. Like you need to answer questions which are open-ended, unlike the previous work. But also you need to present evidence of the answer. Like for example, so there I don't show, that's an example. I don't show the evidence, but like imagine like a span within the video, or saying, oh, here is the moment that you can see this answer being like clear. We propose that. On top of that, we show that for training, this multitask learning, like if you train both, you benefit for a bit, you benefit QA, okay? And we also show that there's still a gap with how a human does, especially for selecting the evidence, okay? Which can be kind of tricky, selecting the evidence. Yep. And I'm gonna move on. Okay, I'm gonna talk about two domains that are overlooked, but now I'm gonna talk about behavior that is kind of overlooked. This work has been published at ACL 2019 with these people here. So the motivation is the following: like, imagine that like you wanna build a system that retrieves videos from your memory, say from your like not like your memory in mind. I mean like the Google Photos or something. And imagine you want to find a moment that you're being praised, but it turns out that moment was sarcastic. You don't want to retrieve that, right? Because actually you're not being praised. Even though on surface it looks like you were actually not. And like these are many other phenomena that are not considered in this community, and we consider in this work. Which in this particular was sarcasm, but there are other ones. The very first argument I make is that sarcasm is great for multimodality because of echo. I want to put audio, but maybe I skip the audio. Because of the following, like we have this example, and then okay, I'm gonna skip the video itself. But anyway, the first person says like really, and the second person says like really, and you get the point, right? Exact same text, different. Yeah, you get the point. So multimodality helps recognize sarcasm, and we show this with the so that's why we build the data set called master, because it's a bit spicy, but not too much, like sarcasm, right? I think that was my idea. I don't remember. That was a while back. It's funny, right? Anyway, multimodal sarcasm detection by the T. Anyway, 690 videos from 4 TV shows, half sarcastic, 5-second duration videos because it's one utterance, but we also include the context, like in a separate video, so you have context, and also include subtitles, something like this. Context, then an utterance, which is either sarcastic or non-sarcastic labeled, okay? And the trust roots. my past. So we have three modalities: text, audio, vision. We extract the features. I'm not going to talk about the details of that. It's in my presentation, but you can ask questions at the end about these details, I guess. But we have the important thing is that we have features per modality, and then we compute like an SVM with like unimodal, unimodal methods, and then multimodal ones in green. The first thing we observe is that from the unimodal ones, interestingly, the visual one was the best. Okay, this is random. But then you have a boost if you use text also of 4.2 absolute. This is a cross-validation setting. But also when we consider a challenging setting, which is we put new speakers in the test set. Actually, we put a complete new show in the test set. You have friends in the test set, and you have Chandler, Rachel, Monica, etc. on the test set. And in the training set, you have like Sheldon and people from the Big Bang Theory. You have people from the Golden Girls, and another show. And here the results are different, showing like that we were having some bias with the vision part. And then the best is the audio one, which is consistent with previous work indicating that tone is important. The tone pattern and the pitch is important for like sarcasm detection. And you have a little boost with text, but it's kind of more negligent. Yeah, can somebody mute me? But ordinal is we're indicating that multimodality is important in sarcasm with this. And we have this data set that is available for anybody to use. Actually got quite popular, and I'm happy about that. People seem to be using it a lot. Yeah. So I'm going to move on to the next section, which is realistic and robust video understanding and evaluation. This section focuses more on evaluation side of things. We published this on ACL 2022. So if we pay attention to evaluation, like we need to assess methods, right? And what is to understand a video? It could be about answering a question, such as what are the three girls doing? Or it could be about describing the content, like the three girls are sitting outside performing a routine with a cat. Or it could be about like selecting one choice of multiple choices. I argue that there are problems with all these current methods of evaluating methods. Multiple choice, the last one. What is the problem with multiple choice? It's vastly employed. The first one is unrealistic. For example, if you use Siri or Alexa, you will say, Alexa, how many people are in the room? 820, 325, and so on. No, you don't do that. Nobody does that. Like, you just want an answer. You don't want to provide choices. And the second reason is that people have shown that like methods learn from the instructors more than the correct answer. It's like, oh, these instructors are very far away from the correct answer. Like Cindy is very far away from anything that happens in the video, so then it must be Caitlin, whatever you're asking. So they don't learn for the right reasons, and then like you're not evaluating them correctly. And what's wrong with free-form video understanding, like captioning? Don't get me wrong, I like captioning. The problem is the evaluation is noisy. It's either you do it manually, which is pain, or you do it automatically, which is super noisy because you employ metrics like rouge and blue and so on. And like, for example, look at this. There's so many diverse ways of describing the content of this video, which is not loading, but it's like people parasailing on the beach. Like what other people are looking. Well, you can guess. Oh yeah, here it is. There's so many ways. So if a system produces any of these, then it's not gonna look like the rest of this, and then you're gonna give it a lower score. So it's kind of noisy. I have numbers for this later. Maybe the next slide. So can we do better? Like on the one extreme you have multiple choice, and then on the other extreme you have to make a system generate a full sentence. So can we do less? Can we generate less than a sentence? And if you think about it, that's actually what questions do. The question typically asks about one piece of information. Like for example, like if you have this sentence, like men on a beach prepared to assist an incoming parasailor, like the underlying part, a question could ask about that aspect, like what are the men on the beach doing? And then you say that. So then you could argue we can build a system that like we generate questions automatically from captions, and then systems have to like answer in open-ended manner. So that will be like an open-ended question answering. However, two problems here. The first one is like if you generate questions and you make systems answer, it can be noisy. I feel like these days maybe it's less noisy, but it's still noisy. Like we did a lot of experiments with that. But more importantly than this, sorry, is that there is still room for diversity. So we created a solution for this. We call it Fiber, and I'm going to talk about it. So instead of like generating questions, why don't we just fill blanks, right, in a sentence? So this is about filling blanks for video understanding. Yeah, right. Like you don't need to generate questions. Like it can be noisy. You just can fill a blank. And then what do we fill? What do we blank? We decided to blank noun phrases because after many experiments, like we also try with verbs and phrases that contain a lot of adjectives and adverbs, and we concluded that noun phrases are the most agreed upon. And because there is still room for diversity still, we collected more correct answers, like all these ones, for example, for this video that you saw before, which some are synonyms of cup and others are like other valid things to say in the sentence. So I'm skipping the data collection like I did the rest, but we based on Baytech. I don't say here, but we based on Baytech. We did extra notation for the validation and test. Here are some human agreement results for validation. We employ two metrics, exam match and F1, which is the same as Rush 1 in this case. This is like a squad style, if you're familiar with squad. When we do one worker out of 9, we have high agreement, and also when we bring new people into the scene, there's high agreement, which we're happy. This is F1. And then the more annotators, the better. I guess it's expected, but we reach very high levels, and we're happy with them of agreement. Compare this to like beta capturing, like if they have more annotator than us, but like much lower human agreement because you have to do the full sentence. And there's a lot of diversity, like I showed before. So we propose a model for this task because many models like don't apply because most models in this area, at least back then, bless you, it was based on like selecting choices. So you have to like present them with each of the choices possible. Like here you have like infinite choices because it's arbitrary length blank filling. We also consider like something based on verb, but verb needs you need to know the number of tokens you're filling, and also the tokens you fill are conditionally independent. So if you fill multiple, like it can give you like gibberish. So back then, like T5 was relatively new, so we based on T5, which was pre-trained on filling blanks. So as a natural fit, we added the video part from i3D, and then we make it fill blanks. And I'm going to present the results now. This thing has a little delay. Oh, okay. Caba performance we showed before. That's the most frequent answer. There is some bias, unfortunately. If we do zero shot, it's kind of challenging. If we fine tune the taxonomy model, it becomes more trivial. And then there's a little boost when you do the multimodal part. And also we consider using a single frame. But it's still challenging. And I think there's still a gap here. And I think it would be more interesting if doing zero shot in the future. But yeah. Sorry. Okay. All right. I'm gonna go to the no. Any question? No. So I talk about data aspects that we contributed on. I talk about behavior that we contributed on. I talk about evaluation, how to solve some of the issues. Now I'm gonna talk about methods. This is a work I did while interning at Adobe with Fabian. It's about practical and scalable video understanding. We published it at BMVC 2022. So how do we use existing methods, or at least back then, 2 years ago or something? Like for video, you grab like a method pre-trained on like kinetics, and then you try to classify it among many actions, right? But what if you like try to include something that was actually not there? Like you went in a winter vacations, and then you wanna find the sledding moments, and you find out that it's not in one of the 700 classes for kinetics. what do you do? So you this thing, okay? You need to like run your data to train the model with some compute, and now it works translating. However, besides like this new data and compute that you need, there's also probably going to incur catastrophic forgetting, meaning that like you recognize learning now, but this new model is going to perform worse on like a city, for example. And there's also, there may be domain gaps, like maybe you gather data from YouTube that is on like cloudy days, and then but it happens to be sunny day, and maybe you're gonna have a penalty in your performance because of that. So we end up needing a new and different model for each task and domain. Okay. So we focus on a different setting, which is like zero shot. In zero shot, you train a model and then you use it as is. Okay, it doesn't matter like open vocabulary, like any text, and we consider two settings: classification and retrieval. Retrieval, like you have a text and then you search for a video. So it turns out that like when we started, like there was clip just came before that. It was great for zero shot, and actually it was having great numbers for video. But it was not made for video. Clip. Let me talk about clip for a moment. Clip is a method that has an image in color and a text in color. And it was so it gives you representation for images and representation for text, and it was trying to compute the similarity between them, and you give them a bunch, and it has to like this has to be kind of equal to the identity matrix or close to. And then at inference time, you want to classify something, saying you have like a dog here or something, and you pass it through all the text classes, you pass them through the color, and then you check which one is the closest. So given that clip wasn't made for video, can we adapt it to make it more prepared for video, but while keeping the robustness? Because it's very robust, like meaning that like, it works well in a zero shot setting, like without like in a new domain it works well. And that's what we did. We created a method we call clip, which is like a little refinement over a clip. We started with a similar setting like clip. You have a visual color, you have a text color, you have the same losses like video to the text and the text to the video, like in the similarity matrix that they showed. That's the loss. We have the level data like in clip, okay, but with videos from 1 bit, actually from a small portion from 1 bit, because this we don't train a lot. This is like a small refinement, which is great, because you don't need a lot of compute. But now the difference, we also do distillation. Okay, we have a teacher network, and then we do distillation. So we're trying to keep ourselves like the student model to keep it close to the teacher, such that it doesn't lose the robustness while adapting to video. Because if you just do fine tuning, you're gonna like be away, and then you're gonna lose robustness. And so we include distillation losses. And finally, we also consider something that has many names, but I'm gonna go by model patching, which is to like recover some of the performance that was lost. Still, you do literally a weighted average of the parameters of the two models, and yeah, this is awesome and it works great. And if you're not familiar with this, there's still like an open research area on why this works. But there's some intuitions are that like the student model is not going to be that far away from the teacher one, so the weights are going to be kind of close in space, and that's one thing that makes it work. Okay. So I'm going to present results. So these are zero shot results, meaning the model never saw this data. We show a boost overall on these 5 benchmarks that we tried on. We also updated like the need of the second step. 0 here would be the teacher performance. If you just do the first step in new data, in new unseen data, you lose performance in zero shot. But when you do the second step, not only you recover it, but also you improve. Okay, and now finally I'm gonna go to the last section, which I'm gonna spend more time on this, and then maybe I'll go a bit slower. Which is about compositional generalization for unseen actions with image text models. Yes. Yeah.
So if you go back about that teacher student model, what's the teacher model here?
It's a pre-trained clip.
It's pre-trained, but So what we do is give them model.
Yep. Any other question? Or in the Zoom? Wait. This is two papers. The first one I'm going to talk about one that we published at start 2023, and then one that got rejected from NACOD, and then it got rejected from ACL. And if I submit on the 16th, it's going to get rejected from BNLP, maybe. But I like the work, and I think it's cool. So the reviewers can, yeah. I cannot say that on camera. I think, right?
Right.
Yeah. Anyway, two parts for this section. It's like Harry Potter, like the last movie is like two parts. But the difference, I don't make videos with this. Or maybe, I don't know. The first one is understanding Eclipse limitations, because we wanted to understand the limitations to then address some. So we propose a framework. So we want to probe the model, okay? So Clip came out back in the day, and then like everybody was using it, and then like it was great, but people were like not understanding what was going on. So we propose a framework. It's based on like you have a caption and you have an image that is aligned, like the girl is standing in the grass, and then you have a negative image in our framework, but it's negative in a special way. You have something standing in the grass still, but it's not a girl, okay? It's dogs in this case. You pass this text and the image through Clip. You get representations. You get scores for the positive pair, and then you get scores for the negative pair, and also a score difference. And independent of that, we get features. For features that apply to this, features that apply to that, and features that apply to both. And then we compute some correlations and importances. We compute the dataset. There's one dataset that came out called SBO Pros, which is a great for probing, actually, in my opinion, because it has pairs of images that differ only, like with respect to the text, only either on subject, verb, or object. Okay, so in this case, it's a subject, what changes. And they have these pairs, and it's great. We actually have the caption also for this, but I'm not showing it here. It would be like the dogs are standing in the rest instead. We computed many features. I'm not gonna go through all of them, but like say, for example, hypernyms. Like building is a hypernym of house. Or things like that have numbers, like how concrete words are. Like beauty is pretty abstract, 2.93, according to a lot of people. And then table, the word table is pretty concrete, being 4.9 out of 5. We computed importance for each features. For the binary ones, we computed like the scores. For when it's true, the score when it's false. Then you look at the difference. For the numerical ones, we do correlation, Pearson correlation with the scores between the feature and score. We compute significant testing to know which ones are significant. And we have several findings. I'm going to show some now. Other ones are in the dissertation. I picked some that are interesting and relevant to the rest of the talk. The first one is that, like, so if you look at concrete words, okay, how concrete the words in the sentence are from the positive image, negative image, and then the difference in green. Again, like this is abstract, this is concrete. You're gonna see, so let's look at the positive, and this is Clip score. You're gonna see an increase. The more concrete the words are, you're gonna see an increase in alignment, in score, when they are aligned, and that's interesting. So all this should be aligned, but the more concrete, the higher the score. First observation, second observation. The negative score increases and it's negative. So those are images that are not aligned with the text, but they also increase. Why do they increase? Because the words are more concrete. Like just because you have more concrete words, it's going to increase the score. And more interestingly, this gap kind of closes. So meaning that like the more concrete, the more confused it gets. So if you have an image and then you have two texts, say one positive, one negative, if the negative is much more concrete, chances are that like Clip is classified. And I thought this was funny to put. Also, the length of the sentences. Clip prefers kind of average length. If your sentences are too short, the score goes low. If they're too large, it goes lower again. But if you're kind of in the middle, you have the better score. Even for the negative images, which are not aligned with the text, the negative image with the text. Though they have some stuff in common, but they're not aligned actually. The picture was showing dogs, not a girl. This is the exact same x and y axis, but here instead of showing average, I show the distribution. I want to make a point here. Like if you have a positive text that is very short, for example, and you have a negative, this is a distribution, right? Half the data is going to be here because it's a box plot. And you have a normal say this one that is negative. You're going to have a very high overlap, meaning that again, Clip can just confuse because your negative text happens to be the number of words that Clip expects. Clip performs much better with nouns than with verbs. Like for example, it gets confused with things like sitting and standing, or like walking and running. Things that people would recognize in an image, like a person running would be like this, you know. Yeah. And finally, I'm showing this. So if you have like completely unrelated images in the sense that like don't have anything in common at all, the score will be like around here. Okay, I don't show it, but it will be around here, around the 0. But these negative scores for these especially graphed negatives are actually very close to the positive scores. Sorry, another big one. And this confirms behavior for Clip reporting to be behaving like a bag of words model, meaning like, oh, these negative images have like little pieces in common, so it's like it's summing some score. You know, like each word is like a contributed score, and then they sum, roughly speaking. So it kind of behaves like a bag of words, and this motivates the second subsection. It's about tackling compositionality issues. So, developing on this bag of word issue, Clip struggles with understanding the subject versus the object in a sentence. Same here. Also, in this work, they show general word changes, like exact same words in a different order, and you get random performance. Struggling with verbs, like I mentioned, like running and crossing. All in all, you can say there are compositionality issues. The scores are skewed towards individual words. I have more examples here. When you have a fine-grained domain, like it starts confused. Like if you learn for the wrong reasons, like the background, and you have everything is about cooking, like it's gonna get super confused. And also, like when you have like common concepts, but they're composed in very novel ways. Like it knows what is to microwave, and it can recognize juice, but like if you try to microwave shoes, it's not gonna recognize it. All in all, it's a lack of compositional generalization. And furthermore, this happens not only with like Clip itself, but also models that were trained on top of Clip for something else. Like DALL-E 2 to generate images, like the text-to-image generation. Like it's trying to generate a yellow book on a red base, and you see that like you cannot attribute the correct adjective to the correct noun. Or even this one that like a panda making latte art, the panda is not making the latte. The panda is being the latte. Object and subject. But no panda was killed with this. Anyway, there's a method that was proposed for fixes called netclip. The same idea as Clip that you have. You have to tell which one is correct for the given text and images. But also during the training, they are carefully crafted negative texts. Here, like you have a black cat sitting on a desk, and they swapped a black desk and sitting on a cat, they swapped cat and desk. So you have especially crafted captions that they have the exact same words in a different order. And the interesting part, so the intuition of why Clip falls into this pile of word behavior is that like during training, like it's presented with like few examples of horse, cat, table, whale, whatever. And then the one is gonna be like, oh, whale, whale, dog, dog, and so on. So the intuition would be like, if you present the same words but in a wrong way, then the model needs to recognize which one is the correct way of using the words, and thus understanding the role of the words in the sentence. So this was great. They show great results for compositionality. However, many problems. First one, they penalize greatly standard tasks. The second problem is that they overfit to a certain style of captions. And the third one is that like they specialize on detecting nonsensical text, like at desk, doing like things that animate objects do, right? Instead of learning the role of the words, and then when you present it with the more challenging ones, they kind of fail. And in particular, I want to focus on, sorry, to the other side. I want to focus on one aspect. So if you want to like, so why do they overfit to like this COCO style? Because COCO is a data set that has, in a way, high quality and low quantity. These models are trained generally on data sets such as Lion that like have large quantity and allegedly low quality in the sense that like they don't align perfectly with the image, the text. They have like we're gonna see examples after this. Why is this important? Because if you want to generate a good negative caption automatically to use it in training, you need some quality. Otherwise, it's gonna be garbage what you generate. And that's why we presented club. We created club, which is a method with 3 steps that solves this. I'm gonna go through them, but the first one is to use synthetic captions. The second one is to use negatives in a similar way to Netclip. And the third one is to do model patching, again, like in the other section. So let's go about the data. Let's go about this first. The synthetic caption. This is an original Lion caption, which is not that bad. This is like a shoe. And then you have children's shoes, 1-for-1, pattern black. But like, it has some alignment. But if you want to like generate negatives, like, let's say you do a swap between, I don't know, 1-for-1 and black. Like this caption is it's kind of like an Amazon.com title. It's kind of confusing. It's not going to change anything. The model is not going to learn. It's going to confuse more than what you do. So it's not very useful. So we rely on a synthetic caption dataset. We didn't generate it ourselves, which has much better captions, like black leather shoes with about detail. Like here, if you do swaps, it makes sense. And you may argue, well, but like synthetic captions are noisy, right? So you're introducing noise. And I would say, well, that's true, but like they were generated with good models and also with a lot of filtering. Like they discarded a ton of images, and then they went through discarding a lot of captions, and so they made sure like the ones they have are pretty good. And they did a user study and they showed they're of good quality. So now that you have good captions and you can manipulate them, and they are a lot, we proceed to the second step. We fine-tune the negatives, but it's different from the one from Netclip. Instead of doing swaps, we do a replacement. We inspire from a method called replace from another paper, but we do many adaptations that I skip. But you want to substitute by something that you know that is just representing the image, like shoes with boots. That is still hard, but more importantly, that is still natural. Because otherwise the model is going to learn for the wrong reasons and it's going to like overfit to understanding nonsensical text. Like very simple things like matching the case. If you don't match the case, the model is going to learn to cheat. To more complicated things like matching the tense, like plurals and gender and number and so on. Yeah, we did a lot of engineering for them to like, I'm skipping, to make sure the model doesn't just learn nonsensical texts. Finally, the model patching, which is again weighted average of the parameters of the models, so you recover performance. I'm going to go through some ablations and some results. Oh, before that, like we use compositional datasets to evaluate, like this one, which has 4 numbers. One of them is like you have an image and 2 texts, same words, different order, and you have to tell which is the correct one. It's called ARO, this one. So first, data ablation. This is without any negative fine-tuning, like without like just normal clip training, but like fine-tuning. We try with Lion and Coco, also Koyo, that allegedly is better in some ways. Also some combinations of Lion and Coco, but it didn't work. And then this synthetic caption dataset called Lion Coco, which is not a combination of Lion and Coco. I know it's confusing the naming, but interestingly, it gives better results on ARO, on the 4 numbers, without negatives. So just changing the quality of the data improves the results. Is this one? Sorry, this one.
Oh, actually,
It's a benchmark composed of like 4 numbers on compositionality. The first one swaps subject and object. The second one swaps attributes, and the other one does more complicated substitutions that are allegedly nonsensical. Yeah. So this was the best. And then when we had the negatives, is great the compositionality actually. Well, at least for this benchmark. There are more challenges ones. I'm gonna go move next after that. Then the patching part, I'm gonna justify it. If you have the pre-trained model, it's gonna do. So this is like pre-trained clip. This is gonna do great on standard tasks. These are this one is ImageNet. And then you have ARO, but it's gonna do bad on ARO. And then the fine-tune one is the opposite. It does great on ARO, but it does bad on ImageNet. Then you do the weighted average for different weights. And then here, these ones are like you're good in both, actually. Here is similar access, like you have 10 standard tasks here, and you have 9 classification tasks. So the 4 from ARO, and then 5 from, I think 5 from sugar crepe, another method, which is, in my opinion, is more interesting. The compositionality is more complicated. Clip, we already saw is there. Other methods like ours and others are there, but when we do the patching, we have the best of both works. And even our method is slightly better on without the patching. This is a concrete example of something that does better than Clip. The one on the top, Clip can do well, a white horse versus a white cat. But then if you like the horse is eating the grass versus the grass is eating the horse, our method does well and Clip doesn't. Also, like generalization to unseen verb object compositions, like there's this data set called React that we saw micro issues, but it also has like things like cutting a keyboard or blending a phone. And our method, these are videos, not images. Our method shows a 4% increase in average precision with respect to the baseline. Finally, we observe improvements in retrieval, like in general normal retrieval, in 4 tasks, in like about 5% recall 5, absolute. It kind of makes sense because our method is better with language in general, and retrieval is more involved than classification in terms of language, so it makes sense. We're happy about this. So wrapping up everything. I'm going to read the research questions and then I'm going to answer them. Can we build a language-based video understanding benchmarks suited for overlooked real-life domains such as daily life situations and nature? We propose new data set and benchmarks for this. We propose a new evaluation format that makes sense for long videos. And we show that the benefits for multitask learning, like when you do QA for selected evidence. Does combining vision and language help better recognize natural human behavior in videos? We introduce a new sarcasm dataset. We show that multiple modalities benefit in sarcasm detection. We show the important, well, I didn't show it here, but in the dissertation, I show the importance of context. Can language be leveraged to build an automatic evolution framework for video understanding that better reflects real-life situations? We propose a new evaluation setup that is challenging, robust, and realistic. Like it doesn't expect people to like provide multiple choices. In data set a benchmark for this. And this is still a gap with the human performance. Grass shampoo. I can see you finished. Can large pre-trained image text alignment models be used for robust zero-shot video understanding? If you eat the food, you have to stay now. You cannot just eat the food. Otherwise, the room would be empty. We present a novel effective strategy to adopt image text model for video for zero-shot. We show considerable improvements with like no cost and inference time. We just swap the weights, and also we updated the components. And finally, for the last question, can we align vision and language models so that they better generalize to unseen verb object compositions? We presented a method that improves compositionality significantly while keeping the performance in like other tasks or improving them. The retrieval improvements, yeah. And also, we propose a method for probing that I feel like is very interesting for other features and other questions that you have. Yeah. And finally, the future work that I think is interesting to look into. The first one is that there's this other common human behavior that I mentioned that like I feel like the video understanding community is overlooking, such as humor, like jokes, and other non-serious type of communication, deception, lies, misdirection, nonverbal communication, facial expression, gestures, and so on. I think this is important. If we want to build systems that like work for people, we need to pay attention to this. And the second one is sorry. No, wait. The second one is the I feel like the fill in the blank framework is really good, and it can be used for other things like captioning or an images instead of like video or like text summarization or like story generation. Like this is an example from Coco. Image captioning, look how diverse the captions are. I feel like fill in the blank can be an interesting framework for like evaluating this. When automatic evaluations on noisy, I think fill in the blank can be interesting. So yeah, I finished with the content. I wanna acknowledge all the people that gave me money during my studies and during my academic years, and also during internships. And by the way, like as I'm here, I also have a public service announcement. Like, you know, I'm leaving the lab, so now Rada is looking for a favorite student, a new favorite student. And this is not generated with a D3. And it's funny, the picture moment. Yeah. Everyone is like raising the camera. It's funny, like it seems like the D3 like pasted an image into another one. Like it's interesting behavior. I didn't edit this at all. Like just stuff. So, because I'm leaving, she needs a new favorite student. Like, because I'm the favorite student. And if you ask her, yeah, Rada, am I the favorite student? She's gonna say no, but she kind of means yes. Like, okay. Somebody who's very smart like me, very dedicated like me, and of course very humble like me. I'm the most humble person like by far. And then somebody like, especially if it's from like South America, from Uruguay or like from this neighborhood. And this is like when you wanna like fill a position and you introduce your own biases, you know. Like, anyway, now but more seriously, I really wanna thank Rada. Thank you, Rada. Because these 6 years have been awesome. And if I have to say it briefly, because I'm gonna go in over time, besides giving me a cheap amount of food and giving me a birthday cake, and probably she has a cake for today, I know her. I feel like
Jeez.
Build yourself, the truth. I feel like you prioritize our happiness. I like the lab happiness before like the technical part, and our safety and our like yeah, and so you give us countless opportunities, and you gave us or you give me great 3 years. So I really thank you. And I have some funny moments. Well, I wanted to show that I tried a lot because I have a ton of badges there, and so many fun moments, and like out of the ordinary activities, like here, this one in this room. I'm here. This one, or going skiing. This one is a cool picture, isn't it? So I feel like you're the world's best advisor. I mean, I'm going to Netflix, so I have to like, as an actor, like, anyway. Thank you to that also. Just a few more moments and with pictures, and then we finish. Like, if you wait like 1 hour, like you can wait. Anyway, we did this white elephant, and then I brought a big box with a banana, and Andrew got the banana. And I got in exchange like pretzels and mustard from whatever. Yeah, like yeah. Thanks to my committee for the support and for the values feedback. I don't have pictures. Thanks to all my internship fellows, I don't have pictures either. 2 times the people that I collaborated with twice. My internships have been awesome. It's been an awesome experience, even the ones that were remote, that you would say, oh, it was remote. But actually it was great. And I'm like super happy about all of them. Thank you to all my collaborators. So I went to Google Scholar, and then I counted the number of papers I had with different people. There are papers, and there are also 3 things that are not papers, so it must be noisy. Yeah, and this also talks about like how much I have collaborated with people in Uruguay overall. With Luis and Ayala especially. Yeah, we have done a ton of projects, so I really appreciate them for like considering me for many opportunities. And we don't have 6 papers with one, like one per year. It's kind of cute, isn't it? And thank you to all my collaborators. Yeah. Thanks, but no thanks from here too. Especially lately. Thanks to my family, I have pictures with my family. Sales, which is in good street view, that's another story for another moment. More with my family. Thanks, Juana. These have been great years, and we did many adventures like entering into a fridge. There are more pictures. Here we're casting for Don't Look Up. And here this picture describes itself. Thanks to my friends from Uruguay for the support. Funny pictures, funny moments. When you graduate in Uruguay, you do this, but not here, okay? Also to my friends from here, some funny pictures. Thanks to the people in Uruguay from NLP. If I have achieved anything, it's only thanks to them because I started there, I spent a lot of time there. I kept collaborating with them, and I hope to continue collaborating still. The picture, there's one also. Thanks also to the people from Spartans, because I feel like I spent great years there, and I learned a lot, and I have kept close contact with them because I have friends there. Thanks to whoever printed that in the hallway. I don't know who was. And finally, thanks to myself, because if I have achieved anything, it's right? Like, I couldn't do anything without me. Yeah, take the picture, I couldn't do anything. Yeah, anyway, thank you.
All right, so time for questions. I think we'll first give priority to the committee. We have Joyce here and then several people online. Whoever wants to start first, if we just speak up. Or maybe you can start, Joyce, if you want to.
Yeah, I'll start. Thank you for the very nice talk. I have a question about this last piece of your work. So your claim is generalization to unseen noun and objects. Yes, right. So then your evaluation is based on these ARO, like the benchmark, right? So how do you, so unseen verb noun, seems like you have to do some kind of a control, right? You have to control, like in the training, you never see this verb noun, and then in the testing, you know, you see this. So how do you address that to reach that the conclusion? Yeah.
Yeah. So the answer part is with error, right? With this one. That's with the yeah.
So this rare act has this control, like the.
So I didn't check myself. So I wanted to check like after the internship, and I lost access to Lion Coco, so I couldn't check. But I think it's good enough to assume that you could argue some of these actions are maybe present on the trained data. But I think it's good enough to assume that they may not be because they're very rare, like blending a phone or like cutting a keyboard. These combinations, yeah, but I don't guarantee that completely unseen. But the argument of unseen is with this data, yeah.
I think in general, like when we say like the composition, we do. I mean, literature, like, there's the verb noun, right? So carefully sort of separate down some of them composition seen in the training and some is completely new.
Yeah.
Yeah. So there's this I think the line of work on the compositional concept learning, particularly looking at how to systematically adjust this kind of composition. So just
Yeah. Yeah, it would be great if we can check explicitly. Yeah, thank you. Yeah.
So can we get some questions from online? Whoever wants to go first. Guillermo,
I had a question. Oh, sorry.
Andrew,
Oh,
go ahead.
I had a question about the. Oh, thank you. I had a question about the fit clip setting. I think I read that you have a separate unlabeled data set that has unpaired vision and language. Is that right?
So
Like, can you tell me a bit more about the underlying setup?
yeah, we actually rely on the same data set that has paired data on WebVid.
Okay, maybe I misunderstood that. I thought it was like unpaired.
No, it's paired. Yeah.
Okay, thanks.
I think at some point we evaluated using unpaired, but it wasn't as successful. Yeah.
Oh, I see. Okay, maybe I just read that then. Thanks. Maybe just because you very quickly clarified that. Maybe I can ask one more thing about the video understanding benchmark. I was wondering if by forcing the model to do fill in the blank, if it favors different architectures than you'd see elsewhere in the literature, like if it would favor methods that can do that are trained to do infilling specifically, or BERT style methods. I was wondering how it fits into the landscape of the different models you might have for capturing.
Yeah, that's a good question. I think we favor certain kind of methods because some other methods you cannot use them directly, you have to adopt them. So yeah, we back in the day we were like favoring methods that are either end-to-end in a way or filling blanks. But I think that like with today methods that you do prompting and stuff, you don't have to favor anything. You can just say like, no, there's this sentence and there's this blank, and can you answer the question to what the answer that would fill the blank or something like that. But yeah, but going back to the original answer, we were like kind of discarding some line of methods. Yeah.
Yeah, like I know in theory you can prompt it, but a lot of times they'll have infilling as another auxiliary objective, or they'll use instruction tuning to have the model learn to fill in blanks. And I was curious if it ends up biasing you toward that style of model.
Yeah, we haven't experimented with those models, but yeah, we're kind of favoring certain type of models. We believe in part that makes the method more apt to real life, because the methods we're discarding are the ones that you need choices in a way. Yeah. But it's a basic point. Yeah.
Other questions?
Yeah, I had, I guess, a bit more of a high-level question. Like, where do you think this field is going? It's like, it seems to me that the best vision, like all the best video understanding models are soon going to be these very, very large multimodal models that are not accessible to academia and are, you know, sort of black box. I'm especially thinking of Gemini 1.5, which is showing really amazing results at a lot of video understanding. So how does this change in the field affect how we're going to think about video understanding models and evaluating them and benchmarking them and making progress on them going forward?
Yeah, that's a great question. It's very broad. Yeah, it feels like the field is moving towards that direction, creating these big models with a lot of pre-trained data that are big in size, that also have a very big context window. Seems like the direction the field is going now, and seem to be great for many tasks. However, I still believe there's room for like other type of work. Like for example, I feel like those models kind of ignore things related to motion because they subsample frames in a large video, so they are going to ignore, like, if you want to recognize, I don't know, somebody opening the fridge versus closing, or things like you need motion. Or also, I believe that like things that relate to like more deeper understanding, like sarcasm or like deception or mimicking or stuff like that, or humor. I feel like they're probably far from solved with these models, even with scale. This is speculation, because they don't seem to be as solved with LLMs either. Like this, like truly, without seeing those data. So it seems like there is still a lot of work to do in that area that doesn't just come with scale. But yeah, unfortunately, the field seems to just sometimes care only about scale or people and training bigger models. Yeah, not sure if I answered the question.
Yeah, I don't think I have a particularly concrete question. I just want to get your thoughts on this general state.
Okay.
I have a similar question to that.
I don't hear you very well, Gisha. Can you?
Yeah,
Right.
I have a similar question, and you partly answered that. You have worked on humor. Now you are working. You have worked on sarcasm. Do you think that what we have now is enough to our research directions nowadays are enough, or we need to add some new things like more data or different ways of seeing things? It's a very broad question, sorry.
Yeah, no, it's good. No, it's a great question. I think that in particular for humor and sarcasm seems to be in my opinion, among the most challenging things. I feel it because they require deeper understanding. You can get a lot of like shortcuts to understanding some of them. In particular, sarcasm you can like get away with visual and audio cues sometimes because there's like a mismatch between what the person would normally say in the situation and how they say it in that situation. Like the example of saying really and like they're not really surprised, they don't look surprised. And when they truly say that they should look surprised. But like for example, for humor seems like we're not just gonna solve it with scale. Seems like we need like some kind of deeper understanding. We need some kind of fundamental change, in my opinion, on understanding humor correctly and being able to generate good humor correctly. Yeah, mostly because like the big models don't show great evidence of this, besides like memorizing some jokes and stuff. So I feel like yeah, we need a fundamental shift for those kind of behaviors. Yeah.
For questions, Santiago, and yeah, great presentation, Santiago. So regarding the last work, I think you analyzed clip, and I wonder, like, if you have any thoughts about how other models like Bleep or models that actually have like stronger language models or stronger language learning losses, let's say. Do you think like they will suffer from similar behavior than clip, or do you think they will actually do better? Like, what's the intuition? Have you compared with them, or any intuition you may have in that space? How do like these dual models with stronger language encoders will do in the setting that you described in the last work?
Yeah, great question. So up to the point that at least we were doing that work, the problems I presented were present in most state-of-the-art, or in all state-of-the-art vision language models. This is like more than a year ago, at least. I'm talking now like the problems like with the Winogrand benchmark or with the Vals benchmark, like the problems I presented at the beginning with behavior like a bubble of words, those kind of problems. For the other problems related to like concreteness and length of sentence, I don't know. And for newer models, I haven't tested myself. I have seen some stuff, like some people were testing GPT-4b on Winogrand, I think, and it still seemed like not super solved. So I haven't seen much stuff on newer work, but it seems to be like still not solved correctly. There is some improvement definitely. I like, for example, the E3 seems to get compositions better than the E2, for example. But it seems like not completely solved, like especially for unseen pairs. Yeah.
Okay, thank you.
That we'll take more questions from the committee. There are more questions, and then we can move to the audience. Any more questions? Joyce, Andrew, Fabian, Guillermo. I do have one question, although I feel I asked lots of questions for the past few years. If you look forward, 5, 10 years from now, what would you want to be known for? Like, what would be seen next?
Jokes. Like if 5 years from now, you mean, or like?
5, 10, whichever.
I don't know. I guess for some cool work that I hopefully do. For being a good person too, also I guess. But I would like to take off with some like work maybe on functionality or something, continue on that area. Yeah, I think it's an exciting area, and I hope people pay more attention to it too. Also, yeah.
It's a big one.
Yeah.
All right, then we can move to the audience. I see Felipe.
Yeah, I have a question. And the question is, and if you would like to put this idea on paper, what programming language do you use? Because some languages have limitations. Example, Python have the limitation. I don't remember the limitation. The question is simple. What language do you use if you want to put this on paper?
He's my 12-year-old brother, by the way. Not very good English, but I didn't know this. I use English. I'm not sure if I understood the question correctly. I use English and.
Yes, programming language.
Oh, Python. Yeah. Did he? Oh, yeah, Python. I used it. Yeah. For most of the work. I didn't write the kernels, fortunately. Yeah. More questions? Yeah.
This is similar to some of the questions, but like a lot of the image generation models like similarly suffer from compositionality problems like you mentioned. Do you think that's all because of Clip or no? Do you think there's like other reasons?
What do you mean? Like what if Blip suffers a model for compositionality?
Well, it's like if you're
saying Clip, right?
Yeah, Clip. Like if you're training an image generation model.
Yeah. I think it's because of Clip, yeah.
And so it's like if you fix that, you might have downstream.
So like for example, Imogen, you know Imogen from Google, like so I don't know why people use Clip text and color only with text to image generation models, honestly. Because it's just a text and color. You could use any text and color. And then Imogen, I think it was the first to use T5, and they show better compositionality. Not perfect, but better. Yeah. Like actually the images from here. These ones, I think I computed them myself, but the prompt I grabbed it from the Imogen paper. And in Imogen, they don't solve it, but they do better than this. Like in Imogen work, I think he managed to get one of these right, for example, but not always. So yes, it's related to the text and color. Like.
Any questions?
Question. Looking at the theme of your research, I was wondering if you give it any thought about, if whatever you came up with is more robust than, large scale models and all that, because, real world settings, right? So you want to, if you want to implement that as a robot, or maybe even helping a disabled person or something, you want to do it in real time, right? So this could be, in a way, used for specific cases, right? So you feel like this is more robust, maybe, or like looking at the future. Because somebody asked, okay, we're gonna have these large models. I'm gonna check GPT, each like everybody else. But I fine tune to my views, right? And I can never personalize it in a way, right? Like you keep changing it and all that. But with this, you could see building useful stuff, right? Is it robust enough, you think? Like we getting to that point?
Yeah, so I have a couple of answers. I think it's a good question. The first one is that I feel like there are two big lines of work. One is like LLMs or generative models, and the other one is like two-tower models, dual encoder models. They have both pros and cons, and this is true in language, and this is true in vision. It's true in language because you have like LLMs, and then you have like methods like sentence word and stuff like that. And it's true in vision because you have like GPT-4b, but also you still have Clip. They both have pros and cons because like LLMs are kind of powerful, but they're slow, they're big, they're impractical, and so on, and brittle. And then, but you have dual encoder models that are like just fast. You just do a dot product, and then you get similarity, boom, fast. If you want to implement search, for example, you can use methods like this. Let me put this slide. Retrieval proofs like. If you want to do search, say you want to like search, you have a given text and you want to search for between 10 million videos, which one is the one showing something? If you use an LLM or something, it's going to be super impractical. While the two encoder models are much more practical because the way you represent the image and text is independent of each other, and then not independent completely, but I mean, it's like late fusion. And then at the very end, you do similarity, so it presents a great advantage in that way. So even if you have a very powerful model, it's still going to be practical in that sense. And in terms of robustness, I feel like our method is more robust in general to, for example, to like changes in the prompt. We conducted this experiment. I'm not sure if here, I do show it in the dissertation and in the paper. So in classification, for example, say on ImageNet, like people, when they do like in Clip, they use like 80 templates, okay? We evaluated our method, for example, without templates, and we saw a smaller drop in accuracy with respect to Clip, meaning that it's more robust to changes in how people write the captions. Yeah, so I guess we have some robustness in this work in that aspect. Yeah, not sure if I'm answering the question. Yeah.
Yeah, I was thinking in terms of computing power too. So coming from other fields of engineering, you're always thinking about, if I want to put this in an actual barcode on a car or whatever it is. Sometimes, smaller models, if they're like I was mentioning, a disabled person, that you might not need 100% accuracy, but you can describe in real time the world surrounding you, right? Well, I'm like, imagine all of a sudden, instead of just using a stick, I have everything being described to me, right? It's good enough. It might make mistakes, but it's amazing, right?
Yeah. Well, I think another advantage of dual encoder models are generally smaller also. Yeah.
Thanks for the presentation. That was very engaging. So I have a question. Do you think the problem of compositionality is the problem of alignment, or is it the limitations of the architecture that we are using? So we're using like dual encoders, like multimodal encoders and decoders that we have. Do you think like using alternative methods is a better solution, or going for better loss functions that can better represent what we want at the end?
I think so. I'm speculating, right? I think it's both, honestly, and I'm gonna say why. Here is it's the data, because if you, in my opinion, probably if you present perfect data in perfect conditions, you're gonna have much better compositionality. But I think it's an architecture problem because there's so much phenomena that you are not contemplating, like the length of the sentence, like why does it perform worse with longer sentences, or the concreteness and stuff like that. What compositionality? What if we look at multi-sentence compositionality? What if we look at conjunctions? What if we look at questions? I feel like there's so much phenomena, like we cannot put everything into the data. So even though if the data can fix things, and actually we showed that in one of the graphs, we showed that when you change the data, actually the numbers do go better without a negative. In this graph, without negatives, you can do better with data. But I think we need some fundamental change, in my opinion, in the language code, especially because you cannot pretend to learn everything just from data. You have to, in my opinion, many people might disagree with me, but I feel like we need more inductive biases to encode these generalizations. Yeah.
Just follow up that. What kind of inductive biases do you
Yeah, I don't know, but like something that like attributes the correct adjectives to the correct nouns. For example, like let's look at this. Let's look at this. Yellow should only influence book. It shouldn't influence. Why is yellow here influencing base? So I feel like we should have inductive biases that consider the correct role of the words.
Structure,
Yes.
some structure.
Languages in the world, they all have patterns in common. Not all of them. Like you can see that like in universal dependency, for example. Why don't we take advantage of that and respect the order of Otherwise, if we don't do that, like these models are great and they can generate the astronaut riding the horse, but then this is so simple still. Yeah, and there's work that like there was one work that it was for stable diffusion. It was trying to force that for example, yellow book. But the attention maps of yellow and books should be similar, and that made the model generate the corresponding attributions. And that's because like yellow was restricted to only kind of like influence book, and I feel like the inductive biases should be similar that way. Yeah.
Any questions? Any more questions online?
I take pictures. Well.
Isn't it the other way around? We're supposed to take pictures.
Oh, okay.
Hey, Gustavo.
Michael, can you? Don't send message now, guys. All right.
All right, so if there are no more questions, thanks to the audience, also thanks to the special guest, Santi's mom, right
Oh, my
here.
mom's up.
And thanks to everyone online. I think what we're gonna do, we'll have to do deliberations. So I'll ask the committee to stay both online and here, and everyone else who don't mind working outside. So
Should I keep my computer or?
I guess you'll want to close that and I'll put just the.
Stop the recording, maybe. What's
Yeah, I will stop the recording and I'll do a break of the.
Yeah. Should I go?
Like, yeah.
Thanks everybody for coming via Zoom. Yeah. Van afuera, van afuera.
Fuera.